Okay, that's some. I'll start with this. Let this be 0 volt, and let me assume the potential of this be X. Then this is cell. The potential difference should be 1 volt, so X plus 1. The potential difference here should be 1 volt. So shall we write X plus 2, X plus 3, X plus 4. Then the drop should be the EMF of this should be 1. So therefore this should be the 1 volt, 2 volt, 3 volt, 4 volt. Now you can ask thing like, why don't you do that one here, 4 volt? If I do here 4 volt, what is the problem? And says I'll do one thing. Nothing wrong. Say like you want to think. So like what you did on top, you do on bottom, sir. Finish over. On your own, can you say that how current will be here 0 because you are selling no current flows, no current flows. So can you make it such a decision? Can you force a circuit that okay, no current, don't flow here? Do we have? Can we control? Nothing, no. So something went wrong. Are you getting the logic? Like, so here, can we really assume like this? Because on your own, don't assume that no current flows in a branch. Only thing after calculation, it has to be concluded here. But you cannot forcibly say that current here is 0. No current through this branch 0. Got the idea, no? So keeping that in mind, so the current in these two resistors what happen, we are making it 0, but if it really happens, we are not sure. So what is the best method? Like solve the problem. If you get current through that means 0. Okay, then it's good. But you should not like directly conclude that no current flows here. Then definitely other student will say, why no current here, sir? No current through this. Other student will say, why there, sir? No current will be through this. Then who is right? Then really it's a very random thinking, no? What students are doing. So something went wrong. So therefore here for that purpose what happened, we are starting like this. Let this be X. This will be X plus 1. See here thinking logically it's correct, but not something, the very concept itself should vanish here. Your logic should not be of that kind. Okay, finally we assume some potentials like this: x plus 1, x plus 2, x plus 3, x plus 4. Then I'm sure that current through this 1 ohm is non-zero. I'm sure that current through this, maybe if I get x equal to 0, okay, current will become 0, that one. But at least I can ensure that the current will flow here. The current will flow here. Okay, after this now, after we got potential, let's try to see the branches. What is the drop across? What is the drop across this branch? You see this x minus 1. What is the drop across this? Also, like the drop across this will be 1 minus x. The drop across this will be 1 minus x. The drop across this will be 1 minus x. The drop across this will be 1 minus x. So then all are having same resistance. So can I push the same current through that as it will be? The current here, let it be equal to I2. Why you are assuming same current? Because all are having 1 ohm resistance and the potential difference across them is same. Let's focus on this. What is the potential difference? X minus 0, x minus 0, x minus 0, x minus 0. Here x that one, or better say x. The drop across these are x that one. So any current can be assumed as the current here will be I1. So what should be the current? Current here will be any direction. So here let me take it in this way.
Minus 22 by 9.
Minus 22 by 9. Yeah, fine. So this is by 1. Now, what is another thing like? So we'll write what is it's quite very easy. You can see now. What is I1? You can write it from here. X minus 0. I1 is equal to x minus 0 by 1. No? Looking in this. Similarly, what is I2? I2 will be 1 minus x by 1. How many unknowns are there? I1, I2 and x. I need one more equation. One more equation with what? Relation between I1 and I2. I'll apply KCL. I'll come in order. This one, the KCL. Here I2 is flowing. I'll do one thing. I'll change the direction of I1. Huh? It'll be easy for us. Huh? Of course, we'll get negative, no problem. I can write easily the equations. That will be I1. Here I2 plus I1. I2 plus I1 or I1 plus I2. Then 2 I1 plus I2. So some other current. 2 I1 plus I2. 3 I1 plus I2. 4 I1 plus I2. But you look at this junction now, there's a problem, no? So like, so definitely open 4 I1 plus I2 plus I1 should be equal to 0. Or if you want to write I1 plus I2 as I, this will be 2I, 3I, 4I, any of the method. So here, what is the relationship between them? 4I1. Again, looking at this junction, here, the equation. 4I1 plus I2 plus I1 equal to 0. 3 equations, 3 unknowns. Solving that, we'll get I1 and I2. Then I will write the potential difference VAB. So this should be 5I1 plus 4I2 equal to 0.
Sir, why is it equal to 0, sir?
The algebraic sum of currents. KCL?
Yes.
So solving equation 1, 2 and 3.
Sir, I2 should be x minus 1 by 1, no, sir.
I2 should be, I made changes, no? I2 should be
X minus 1 by 1.
I1 is, okay, I assumed I1, no? I1 should be 0 minus x. I think, correct, no? I1 should be 0 minus x by 1. I2 should be 1 minus x by 1. Fine?
Yes, sir.
Yeah, this will be. Okay, solving 1, 2, 3. So we'll get I1. Once you know I1, then we can write potential difference. So VAB, it should be VA minus I1 into 1 plus 1 plus 1 minus VB 0. Get substituting value of I1, we'll get the required answer. VAB will be minus 22 by 9 volt. So definitely even node analysis also very lengthy here. You see that's what I'm suggesting is like what all we have the standard methods. Even that node analysis also very difficult here. It's a very lengthy that one. It's not that this is a standard one. Means you can't just conclude that as okay, I'll use this one for everywhere. So how do I come to know in exam? Definitely